This lesson's your chance to get in some good review about some of the basics of angles. Let's start out with what is an angle. Here's a diagram of one, and in this diagram you see that there are two rays, but those two rays share an endpoint. That's exactly the definition of an angle. It's two rays with a common endpoint. Now an angle has specific parts. Most important might be the vertex. And the vertex is that common endpoint that we talked about. So we have the vertex, which is the common endpoint. And then we have the rays, which are considered the sides and sometimes called the legs of the angle. So there are two sides. And then there's sections from the angle. And you might want to grab a colored pencil, but all of the region in between those two rays would be what we call the interior of the angle. So any point that we would find in here would lie in the interior, and then this outer portion out here, that would be called the exterior of the angle. So let's list out the parts we can name. In this angle, I would call, well, let's just put some letters on here. Let's put a point on one of the sides so we can name the rays. Let's call the vertex A, and then let's call this C here and B here. So we've got the vertex, which is point A, and then we have two sides, the rays. Starting at A, we have ray AC, and starting at A, we have ray AB. Now to name an angle, there are different ways you can see that. Let's take a look at all of them. One of the ways you would name an angle would be to simply name its vertex. So this might be called angle, here's the symbol. It might be called angle A. But sometimes there are more than one angle that have that vertex, so you have to be more specific. And in that case, you have to name a point that's on each side as well as the vertex in a particular order. So the order that you would do it in is starting on a side, you would name a point on a side like point C. Then you would go to the bend, like at point A, and then finally you pass through point B, kind of like a dot to dot. Start at C, bend at A, then pass through B. So it would look like this. We would start with our angle symbol, and then we would call this CAB. Now you can reverse that and you get the same result. I could start at B, make my bend at A, and then finalize through C. So I could call this angle BAC. Probably the most important thing to always keep in mind, though, is that that middle letter, the one you name in the middle, is always the vertex. And then once in a while you'll have a picture where they'll just put a little number and they'll put it in the interior near the vertex, like the number 1 here. And in that case you can use that to name your angle as well. This could be called angle number 1. All right. Well, we've had congruent segments, we also have congruent angles. How do we see those? Congruent angles simply mean that they have the same measure. So be careful with this, because sometimes you'll see rays that aren't drawn the same size. I might draw an angle like this and say this is 40 degrees. And I might draw another angle, but I might just extend the rays out longer. How long is a ray? If you think about it, they're infinitely long. So even though I drew this one shorter on the paper, it still goes forever. And if this is 40 degrees, then it also is congruent to the first one. So let's write that. Let's call this angle T, and let's call this angle R. We could make a statement that would say that angle T is congruent, you'll remember this symbol, congruent to angle R, because they have the same measure. So let's look at some types of angles. You've seen some of these before, and I want you to make sure in your notes that you write down examples. There are 4 different types of angles. You need to make sure you get their name and a picture of what an example would look like. So we have this demonstration, and it shows that we have 0 degrees so far, as we have 2 rays that are just laying right on top of each other, going the same direction. But as I open those 2 rays apart, I can see that these angles get bigger and bigger, and these are all acute angles. Acute angles are shown here, and they stay acute until we reach the magic number of 90 degrees, when you see it's changed to a right angle. So acute angles are less than 90 degrees. A right angle is exactly 90 degrees. And as we move beyond the size of a right angle, then it turns into an obtuse angle, larger than 90 degrees. How far do we go before we can't call it an obtuse angle anymore? Well, the magic number there would be 180 degrees, and that's our fourth type of angle. A straight angle has 180 degrees in it. So be sure you get those recorded on your note sheet. So in our examples, we're going to look at how to name some of these angles. Our first one in our diagram, we're supposed to name a right angle. Remember, we're looking for the 90 degrees or that little square mark, and we see it right here. So I want to name this angle, and I'm going to start on this side and name this angle A, bend it D, and B. So this would be called angle ADB. Think about what another name for that would be correct. You can say that in reverse, angle BDA. Just be sure that that middle point right there is your vertex. Okay, now we're looking for an acute angle. Those are the little baby ones. They're so adorable. And we're going to see one right here. It's angle 1. I think that's probably the easiest way to identify it. But let's call this angle 1. Or let's, for practice, do the three-letter name on that. Let me come in this direction, and we'll call this C, bend it D again, and then pass through B. So this could also be called angle CDB. There's a third name if you want to write it down. And finally, an obtuse angle. We're looking for something bigger than 90 degrees. There's a third angle here that we haven't talked about yet, this wide obtuse angle. Call that angle ADC, also known as angle CDA. Our second example, we're going to name and classify the angles in the triangle. There are 3 angles in the triangle. I'm going to start with this angle here with the vertex R. Remember, if there's no confusion, if there's only one angle at that vertex, then you can go ahead and just call it the vertex name. So let's call angle R. And what kind of classification would we give it? That square indicates that that would be a right angle measuring 90 degrees. Our next angle is right here, angle T. And angle T with a measure in there of 45 degrees, so that's going to be our little ones. Those are acute. And our third angle is angle Y. And so angle Y, that's also 45 degrees, just like angle T. That's going to be acute as well. Now while we're here, we're going to do number 3 and identify any congruent angles. Any of these angles that have the same measure. That's a pretty obvious one. I see here angle T is 45 degrees, and so is angle Y. So I might mark those with a tick mark or 2 to show that they're a match. So I would write here that angle T is congruent to angle R or angle Y. And that's all there is to it. And hopefully this was a good review for you.